Assalamualaikum. Hello there. My name is Muhammad Haji Zafrin bin Alwi. I am a student from University Technology Malaysia, Melaka, from course BMMMM, and you're watching my first YouTube video about presentation on diodes and its application. So let's get into it. Firstly is an introduction to diode. A diode is an electric device that permits the flow of current only in one direction and restricts the flow in the opposite direction. The most ordinary sort of diode in current circuit design is the semiconductor diode. Even though additional diode technologies are present, the word diode is traditionally allowed for tiny signal appliances. When a diode is positioned in a simple battery lamp circuit, then the diode will either permit to or stop flow of current through the lamp. All this depends on the polarization of the volts applied. There are various sorts of diode, but their fundamental role is identical. The most ordinary kind of diode is silicon diode. It is placed in a glass cylinder. Diode can conduct only in one-way direction. We have to understand the condition on when the diode is on state or in off state. Okay, next is the function of the diode. The key function of diode is to obstruct the flow current in one direction and permit the flow of current in the other direction. Current passing through the diode is known as forward current, whereas the current blocked by the diode is known as the reverse current. It is an electronic device that results from the fusion of p-type material and the n-type material. These are the types of diode. As you can see here, there are about 22 different types of diode, and I will be explaining about 5 kinds of diode. Firstly is the Zener diode. Zener diode works in reverse bias situation when the voltage attains the breakdown. It is also useful as a voltage regulator. An even voltage can be attained by insertion of a resistor across it to limit the flow of current. Another type of diode is known as LED. Light emitting diode or LED is a semiconductor appliance that produces visible light beams or infrared light beams when an electric current is passed through it. Visible LED can be seen in several electronic devices such as microwaves, number display light, brake light, and even camera. LED come in various colors like orange, red, yellow, green, white, and blue. The blue and white color LED are more costly compared to the other LED. It is because the color of LED is decided by the semiconductor substance, not by the coloring plastic of the body. This is another type of diode. This is known as the Schottky diode. It is also known as a hot carrier code. It is a solid-state diode in which the joint is shaped by the contact of a metal semiconductor. The hot electron diode is generally made up from N kind of material or slightly doped substrate and a metal like aluminum. On the next type of the diode, this is the varactor diode, or also known as varicap diode, is a voltage variable capacitor. When this diode in reverse bias, the width of the depletion layers increase with the reverse voltage. This kind of diode is used for electronic tuning, harmonic generator, and parametric amplifier. This is the last type of diode. It is known as a tunnel diode. It's a highly conducting two-terminal p-n junction diode doped heavily, approximately 1000 times upper than a usual junction diode. A tunnel diode is also known as a Esaki diode. Esaki diode is named after Esaki diode, who is a Nobel Prize winner in physics for discovering electron tunnel outcome employed in diodes. Diode that exhibit phenomenon known as a negative resistance. This type of diode is also used for oscillators and amplifiers. This is operation for the diode. A diode starts its operation when a voltage signal applies across its terminal. A DC volt is applied so that diode starts its operation in a circuit, and this is known as biasing. On mode of the diode is attained by forward biasing, which simply means that higher or positive potential is applied on the anode and on the cathode. Negative or lower potential is applied of a diode. Off mode is of the off mode is attained with the aid of reverse biasing, which simply means that higher or positive potential is applied on the cathode or on the anode. Negative or lower potential is applied of a diode. So this is we will talk about a common application of diode. There are several types of application of diode, which is a rectifier, clipper circuit, clamping circuit, reverse current protection circuit, in logic gate, and voltage multiplier. I will be explaining a few types of application of the diode. Firstly, which is a diode as a rectifier. A rectifying circuit converts a AC voltage, which is an alternating current, into pulsating DC voltage, which is an unidirectional current. A rectifier circuit also allows current to flow only in one-way direction. Half-wave rectifier is a rectifier circuit with a single diode that conducts current during positive or negative half cycle of input AC signal at a rate determined by the input frequency. Most common and important application of a diode is the rectification of the AC power to DC power. Different type of rectifiers circuits starting from the basic type of this rectifier are half-wave, full-wave center tap, and full-bridge rectifier. This is the half-wave rectifier. During the positive half cycle of the input supply, anode is made positive with respect to cathode, so the diode gets forward bias. This results to flow a current to the load. During the negative half cycle of the input sinusoidal wave, anode is made with negative with respect to cathode, so the diode gets reverse bias, hence no current flow to the load. Diode convert AC to DC in process called rectification. Diode only convert for one half of the AC cycle, the remaining half of it either all positive or negative. Next is the diode in clipping circuit. This is the example circuit of the diodes and also symbol. The clipping circuit is also known as limiters, amplitude selectors, and slicers. During the positive half cycle of the input supply, anode is made positive with respect to cathode, so the diode gets forward bias. This results to flow a current to the load. During the negative half cycle of the input sinusoidal wave, anode is made negative with respect to cathode, so the diode gets reverse bias. Hence, no current flow to the load. Electronic circuits that have ability to clip off a portion of the input signal without distorting the remaining part of the alternating waveform. This is an example of the clipper circuit. As you can see here is a clamping circuit. It's also known as a DC restorer. Add or restore a DC level to an electric signal circuit that shifts the waveform of the input signal either all above or below the reference voltage. Yeah, it is used to shift or alter either positive or negative peak of an input signal to a desired level. Depends on diode configuration. In positive clamp circuit, negative peaks are raised upward so negative peaks fall on the zero level. In negative clamp circuit, positive peaks are clamped so that if downward such that positive peaks falls on the same level, on the zero level, sorry, often used in TV. This is type of sample of clamping circuit. So lastly, the conclusion. The diode can change the AC input to the DC output because the diode just allow current flow to it in just in one direction only. Every circuit are given different type of output voltage supply and different type of output waveform. The diode can become an insulator when in reverse bias and also can be a conductor when in forward bias because that is the same time resistance become low and can make the current easily flow through diode. I think that's all for my presentation. Thank you.